just a different way to look at this. Maybe make it easier for people to understand it, where I'm actually giving you values for your bacteria and for your fungi per gram. So bare soil, strictly bacterial. Nitrate, the only form of nitrogen. When we start getting a little bit of plant material in there, we're going to get a little bit of fungi coming along. But still very nitrate dominated, weedy species. We start moving to our 50% of our biomass is fungi. And now we got a little bit of ammonium coming in. We get rid of most of our weeds. As we keep moving along into our row crops, our veggies, equal fungal biomass, way more productive, equal amounts of fungi and bacteria. Fungal dominated, we're into our shrubs, our deciduous trees, up into the old growth systems. When we get to the Washington State, up in the Olympic Peninsula, this number is 70,000. And when you look at that pie chart, and you look at how much the volume of a soil is sand, silt, clay, it's a teeny tiny amount of that soil is sand, silt, and clay. 80 to 85% of the weight or volume of a soil is fungal biomass. So you got to pay attention to the system. I suspect that as we go through succession, that pie chart is going to shift. It's, maybe down here, the biology is, only 5% of your pie chart. But as you move into more productive systems, the biology is going to get to be more and more of that pie chart. By the time you get here, the biology is most of the pie chart. So, nitrate, balanced nitrate and ammonium. Been documented by a number of laboratories beside my own. So, why isn't everything an old growth forest on this planet? If Mother Nature is pushing everything that way, why isn't everything an old growth forest? Something is taking us from this and making it go backwards. What is that called? It's called disturbance. So, take a look at this landscape. All of this was, the end of the 18th century, all of this was old growth forest. And human beings, Europeans, came through here and mowed it all down. We needed wood for tall ships. And so it all went out on the ocean. This mature forest has grown back in the last 100 and some years. How come this did not get back to that stage? What's causing this to be stuck in this very early succession of mostly weeds? Look at the erosion, look at the damage to every part of that ecosystem. It's called grazing, and inappropriate grazing. And those animals, the sheep in here, are coming along. They're spending way too much time. They're not controlled. They're spending all this time in all of these watersheds, compacting the soil, going backwards in succession. Now look at over here. Why doesn't this look like that? Same number of sheep on this property as on this property. Because these are controlled in their grazing. They do cell grazing over here. The animals are kept in very small areas with electric fencing. They're only kept on a certain area for about 12 hours, and then they are moved on. Historically, that's the way animals graze. It is not appropriate to leave your animals to just go wherever it is they want, because they're going to spend all the time in the most fragile part of that system. So, disturbance is what we're looking at. So, here we are, what are the disturbances that are going to push you back, and how far back are you going to go? Think about a fire in Yellowstone National Park. Back about 30-some years ago, there was a pretty devastating fire. I had to really enjoy some of the representatives in Wyoming that said, well, Yellowstone National Park has been destroyed, we should sell it. As if it's not going to come back. So some parts of the park, the fire was just a light understory burn. Didn't even kill the trees. The next year, the old growth forest the trees grew better. A larger ring. Okay, some places the trees burned. Part of the soil started to burn. And what came up was some pretty nice pastures the next year. We increased the herds of bison and elk and antelope because there was more grazing for all of the animals within the system. But then pretty quickly, a lot of these, not all of them, but a lot of these places starting to go back to old growth. The serotinous cones germinated. Within 2 or 3 years, we had young stands of the overstory conifer tree, and it was already returning. In some of those areas, the trees are 30 feet tall at this point. Some places, the fire was more intense. It was hotter, it burned longer, the temperature in the soil got up higher, so we lost more of the organic matter in the soil. And what came up the next year was weeds. Some of those places, within the next year or two, started along the course of succession right away. Some places are stuck in the weeds 30 years later. All we have in some areas is predominance of weeds. How come it's not coming back? How come the biology isn't getting reestablished here? Now, if this was my property, I'd come back in here and I would put the biology back because I don't want weed fields. But this is Yellowstone National Park. And by law, all that we as park rangers can do is stand back and observe. It's a great laboratory for us to see what happens. We can get in there and we can assess the systems, but we can't disturb it. We can't be in there changing it. We can watch, and that's it. Some places in Yellowstone, the fire burned so hot for so long, the fuel load was so great that it melted the silica in the soil, and the soil surface turned into glass. Went all the way, back there. 2 years ago, I was invited to come back to Yellowstone National Park and assay those areas. And the last place where the soil surface was completely glass, covered by, it was a really thick layer of glass. The silica had melted so deep. Finally, started getting some weeds on the system. How long is it going to take for those places to come back and become an old-growth forest? Depends on the life. All the different factors. So think about every place on this planet. It started out here, and then Mother Nature started building soil, and then a disturbance came along and it went backwards. You know, here comes the flood, so it goes backwards. And then she starts to rebuild, and then another disturbance comes along, and then she starts to rebuild, another disturbance, she starts to build. It's kind of like the yin and yang of ecosystems. Where's your property? Where are you on that back and forth, back and forth? And can you move your ecosystem along to what you want to grow? Well, of course you can. So we have to understand this biology in the soil.